Okay, this is IGCSE Physics 062542, October, November 2019, question 4. Okay. Uh, a student carries out an experiment to determine the thermal capacity of a metal block. The block is heated by an electric heater. Whoa. Okay, the block is heated by an electric heater for 23 minutes, and the current is 3 amperes at a potential difference of 12. The temperature of the block rises from 20 degrees Celsius to 70 degrees Celsius. Calculate the thermal capacity of the block. So they're asking you to find C. Okay? And now be careful. When they say thermal capacity, it's like in the Sabbath syllabus when we have specific heat capacity and heat capacity. Thermal capacity is heat capacity, the capital C. And you guys know capital C is the same as M times small c. Okay? So we're gonna write it like this, okay? What is m times small c equal to? Remember, our formula was Q is equal to mc delta T. And remember, Q is energy. What's energy equal to when you have current and voltage and time? Current energy is equal to power times time. So power times time is equal to mc delta T, right? And power is what? It's I, V, T is equal to mc delta T. And remember, in this case, we're trying to find capital C, which is MC. So we're gonna rewrite this as IVT is equal to capital C delta T, right? So how would we find capital C? It's equal to IVT over delta T. Okay, so it's gonna be equal to the current 3 times the voltage, 12 times the time, which is 23 minutes. It must be in seconds, over, so we multiply by 60, over the change in temperature, which is 70 minus 20. So it's a 50, it's a 4 mark question. I'm not sure why. So let's put this on our calculator. 3 times 12 times 23 times 60 over 70 minus 20, which is just 50. And we're going to get 993.6. So we got 993.6. We need to make it to two significant figures. Okay, two significant figures, right? Because here it's 2SF. So it's going to be 900. Sorry. Yeah, people write it as 990 because in the Cambridge syllabus this is counted as two significant figures, but in our Sabbath syllabus we write it like this as two significant figures: 9.9 times 10 to the power of 2. Okay, so 9.9 times 10 to the power of 2. What's the unit? What are we dividing by? Remember, C is equal to, where would you write it? C is equal to uh, Q over delta T, right? Where our capital C is equal to Q over delta T, right? What's the unit for Q? It's joules. What's the delta T? It's degrees Celsius. So we could say oh, joules per degrees Celsius. Okay, the unit is a must. Your answer is wrong if you don't have a unit. So basically, they are looking for, see if you use the energy or Q as IVT, and we wrote that over here, IVT, okay, uh, and then a value for it, and then we found this is not really needed. We directly found three times. Okay, yeah. So basically, in the marking scheme, if it says C, it basically means you don't have to have the certain amount to get the mark, as long as yani it's part of your working. 3 times 12 times 33 times 60, which is 50,000. As long as it's part of your working, then you get the mark for it. It's fine. Okay, so like we said, 990 needs to be 2SF, so 9.9 times the power of 2. Two metal spheres of different diameters are heated to 900 degrees Celsius in a hot oven. The two spheres are removed from the oven. State and explain any difference in initial rate of emission of radiation or thermal energy between the two spheres. So basically here, when we say they have different diameters, that means they have different areas. Okay, so they're saying when they took them out, the initial rates of emission of radiation of thermal energy. So they lost heat, right? They're both losing heat. It's 900 degrees, you take it out of the oven, it starts to lose heat. But one of them is going to have a different rate of loss than the other. How are you going to know which is which? Okay, obviously, the larger sphere will lose heat faster. Why? Because it has a greater surface area. A greater surface area. Let's check the marking scheme. The largest feat loses energy faster. Why? Because it has a greater surface area. You have to say the word area. If something's underlined in the mark scheme, that means it must be said, okay, for the mark. One hot sphere is now heated in a hotter oven. Okay, state and explain any effect on the rate of emission on the radiation from this sphere compared to the other ones. Now, since it's in a hotter oven, how is the rate of loss of heat going to be? Obviously, it's going to be faster. Why? This is the state. Why? Because it was heated to a higher temp. Okay? So, think about it like this. If you have a 900 degrees Celsius one and 1500 degrees Celsius, which one's going to lose heat faster? Obviously 1500 because it's richer. It's ready to donate its energy. Okay, think of it like that. So like that, we're done question 4. Thank you so much for watching. Good luck.